Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University School of Sciences, SOS Others Programs. Appreciation Course on Environment, AC Block-3 Improving the Environment. Unit 11 Global Issues and Concerns. 11.1 Introduction. This is the last unit of the course, and by now, you must have acquired a good knowledge about the importance of various natural resources, their uses in development and the effect of developmental activities on the environment. More importantly, the need to properly manage the natural resources and environmental conversation have led to the concept of environmental quality management and use of eco-friendly technologies. With such a wide exposure of various aspects and implementation available in the Indian context, as dealt in Unit 10, it is quite appropriate now to know various environmental issues which are a matter of concern for people across the national boundaries. This unit covers both the transboundary and global issues. These issues have become topics of hot discussions at various fora in last 2 decades. The transboundary issues would include use of nuclear energy from its safety point of view and various aspects of biodiversity protection. The global issues like ozone layer depletion, global warming and climate change had been matter of debate for long. Here, we have discussed the causes, as well as the effects of these phenomena and the measures taken to deal with these issues. The issue of hazardous waste disposal is no less alarming. The amount of hazardous waste is accumulating day by day, and dumping of such waste by the developed into the developing countries have been a matter of concern for both the human health and the environment. Some such incidents are highlighted in this part of the unit. In the present age of gene revolution, although better human health and safer food crops are envisaged with the use of biotechnology, but certain environmental, social, ethical and economic aspects are also associated with the use of biotechnology. Some such concerns are raised in the section on biotechnology. Finally, we would question ourselves that in this era of modern technology, which aims to provide comfortable living, are we safe? We are all under a threat of attack by weapons, be they chemical, nuclear or biological. The discussion includes some examples and effects of these weapons. To meet the challenges posed by the above issues, measures have been initiated at international level in the form of conventions and treaties. Broad features of such conventions and treaties have been briefly enumerated in the unit at appropriate places. In addition, some useful websites have also been listed for further relevant information. Thus, this unit is a window to the major global concerns. Let us start our journey and join hands to save the environment. Objectives. After studying this unit, you should be able to explain various aspects related to environmental aspects of nuclear power plants, discuss major threats such as desertification and recent trends to monopolize the biodiversity and appreciate the need to protect the biodiversity, list the causes and effects of ozone layer depletion, give reasons of global warming and relate it to the phenomenon of climate change, discuss the environmental implications of transgenics in creating new life forms including social and ethical issues, give examples of chemical, biological and nuclear weapons and comment on the dangers associated with them, and give names and objectives of various international conventions and treaties related to various environmental issues. 11.2 Transboundary issues. In the last 2 decades, certain issues have been a matter of concern not only to the people of a nation but also to those belonging to other countries nearby. This is because of their impact across the boundaries of the nations. In this section, we will take up 2 such transboundary issues: nuclear accidents and biodiversity. The Chernobyl accident was even reported by the people in another country, Sweden, and not by the authorities of the country when it actually happened. The threat to biodiversity through monopolization by desertification, patents appears also from part of this section. 11.2.1 Nuclear accidents. Chernobyl. Although nuclear energy is an alternative non-renewable source of energy, why is the opinion of people reversing about the construction of nuclear power plants? In this subsection, we will try to find out an answer to this question. Nuclear energy is the energy obtained from the nucleus of an atom. The atom contains a positively charged nucleus situated at the center of the atom and the electrons which reside in the extra-nuclear space. The nuclear power is obtained from the atoms of various elements by either fission or fusion reactions. Fission involves splitting of atomic nucleus into smaller fragments, whereas in fusion atomic nuclei combine to form the heavier nuclei. In a fission reaction, uranium is used as a fuel. Naturally occurring uranium contains three isotopes, 2U, 99.3%, 2 U 0.7%, and 2U, 0.005%. The 2 2J are radioactive, but only 2U is fissionable. Enriched uranium is obtained by the process of enrichment of uranium, which increases its concentration from 0.7% to 3%. The bombardment of 2U with neutrons produces fission fragments, barium-4A, and krypton, 93 Ca, neutrons and heat, as is shown in figure 11.2. The speed of the released neutrons is moderated using water as moderator so that the probability of their fission with other 2U atoms increases. Thus, a chain reaction starts which liberates a large amount of heat. The heat so generated is used to produce electricity. Look at the screen. The core of the reactor is enclosed in a stainless steel reactor vessel, and the entire reactor is enclosed in a building made up of reinforced concrete. From the safety point of view, the reactor is said to be critical when a self-sustaining chain reaction takes place in it. Worldwide nuclear energy is harnessed to meet the energy requirements, but accidents at the nuclear power plants in the recent history and their resulting effects have put a question mark on future use of nuclear power. Although the chances of nuclear power plant accidents are very low, but the accidents do happen. One such accident has already been mentioned in Unit 5, viz. the 3 Mile Island, which occurred on March 28, 1979 in Pennsylvania. Another at Chernobyl happened on April 26, 1986 at Ukrainian village of Pripyat, but was reported by workers at a nuclear power plant in Sweden. On April 28, 1986, they noticed that the increased level of radiation was not due to radioactivity from their nuclear plant but due to prevailing winds from the Chernobyl power plant, where the worst possible nuclear accident had occurred. The accident happened because the engineers at the plant violated the safety rules and did not follow the operational procedures. This resulted in the failure of supply of cooling water, causing the temperature to rise above 3000 degrees Celsius. The uranium fuel melted and the graphite that surrounded the fuel rods ignited. The resulting explosion destroyed the top of the building, paving way for burning graphite, molten uranium and radioactive ash up to 1000 meters into the air. There was no public announcement of the accident for 3 days, and the village of Pripyat was not vacated for 36 hours. About 7 tons of fuel containing 50 to 10 million curies was released, which amounted to about 5% of the reactor fuel. 31 persons were officially reported to have died from direct effects of radiation. The reactor had been buried underground, where it would remain embedded for thousands of years. But the effects of radiation on the environment would last for long times to come. Studies report an increase in the number of childhood thyroid cancer cases in Belarus, Ukraine and the Russian Federation, the countries that were worst affected by the accident. It is expected that about 16,000 people would die because of cancer and genetic defects of radiation in 50 years' time since the accident. The contaminated soil, surface water, groundwater, vegetation present a hazard to both plants and animals. A 10-kilometer zone was initially evacuated, which was later extended to 30 kilometers. About 115,000 people were evacuated. The evacuated land is also unsafe for habitation. The amount of fallout varied from area to area, and nearly 3 billion people received varying amounts of radiation. Many countries filed suits in international courts for the compensation of damages. The total cost of accident would probably exceed $220 billion. Following these accidents, all IAEA members signed an Agreement to provide timely information in case of a transboundary nuclear accident. After Chernobyl, the number of nuclear power plants being built has reduced. But since the nuclear power generates energy in a cleaner way, the research to build safer nuclear power plants goes on. Thus, safety is one of the major issues in the nuclear power generation. Another challenge being the management of nuclear waste generated during various stages of this process, which is discussed in sub-sec. L1.3.3. In addition, other issues of concern related to nuclear power plants are emergency evacuation plans in case of an accident, bearing of liability in case of an accident and payment of compensation thereof, diversion of nuclear fuel for production of nuclear weapons, zero procurement of nuclear fuel such as plutonium terrorist organizations and its use for destructive activities, vulnerability of nuclear power plants by terrorists as well as other countries in case of a war. 11.2.2 Biodiversity, desertification, patents, IPRs. The biodiversity or biological diversity has a magnitude that is beyond our limits of knowledge. We do not exactly know the total number of species present at a global level. The number may vary from 10 to 100 million. The majority of these species are found in tropical forests. The cutting of forests deprives many species from their habitat and hence they may become extinct. This loss of biodiversity cannot be reversed. Once the species are lost, they are lost forever. Some of these species might have had uses such new crop plants, fibers, medicinal plants, etc. Biodiversity is threatened by desertification as well as by monopolization of life forms and biological resources by patenting them. These commercial interests should not be allowed to dominate over the basic needs of food and health of humans. The conversation of biodiversity is important both from the economic and ethical aspects. We have to preserve the species for our future generations, and we should also not forget the ecological role of various species. Deserts occur naturally on Earth in regions where water is scanty and soil is inorganic, coarse and sandy. There are 5 natural warm desert regions on Earth. The actual desert is 43% of the land on Earth, whereas that estimated on the basis of climate is about 33%. This additional desert area is a result of human activities. The deterioration of land in arid, semi-arid and dry subhumid areas due to human activities and climate changes is called desertification. Desertification affects about 1 billion people, which constitute about 1/6 of the world population. It has largely occurred in the regions of Asia, Africa and South America, and over 250 million people are directly affected by it. These people are also the poorest, most marginalized and politically weaker citizens. The causes of desertification being bad farming practices, overgrazing and cutting of trees, deforestation. It is also caused by human activities and climatic variations. It occurs because of overexploitation of dry land ecosystems and inappropriate land use. It is a major economic, social and environmental concern of many countries. The United Nations Conference on Desertification, UNCOD, in 1977 adopted a plan of action to combat desertification, PACD. But it was later observed that the land degradation problem intensified. At Rio de Janeiro, in 1992, the United Nations Conference on Environment and Development, UNST, called for an integrated approach to promote sustainable development at the community level. With the establishment of Intergovernmental Negotiating Committee, INCD, in 1994 and its negotiations, a convention to combat desertification was adopted on 17 June, 1994, which came into force on 26 December 1996. At present 179 governments are party to this convention. A bottom-up approach is suggested in the action programs which involve the popular participation and creation of enabling environment by the governments. The links to details of the convention, its action programs, conference sessions, reports and other related information is available at http://www. UNCADO. Intel Conventional Text Preface. PHP. The other useful site is http://www. UNCADO. Intel Publish Info/Fact Sheets/menu. PHP. In addition to desertification, another major threat to biodiversity is monopolization of various life forms and biological resources. Many species and their uses are being patented. Let us now study the impact of such patents on biodiversity. The intellectual property rights, IPRs, include copyrights, trademarks, trade secrets and patents. Patents vest exclusive monopoly ownership's rights over the patented matter, i.e., the patent holder has due right to exclude others from using, making and selling the patented subject matter for a certain period of time. IPRs and patents have become a matter of concern because of mega mergers of multinational companies in the life science industry, which involves commercial sale of seeds, pesticides, food and pharmaceuticals. Thus, multinational companies can monopolize and control the supply of these products. This essentially means an increase in their prices. In addition, the control on essential resources such as seeds, drugs and food indirectly means a control over the fundamental rights of access to food, health and nutrition. WTO Agreement on Trade-Related Aspects of Intellectual Property Rights, TRJPS, was negotiated during the Uruguay round. Article 27.3b relates the provision of TRIPS to biodiversity. It envisages the protection of plant varieties either by patents or by effective sui generis, unique or of its own kind, system or by a combination thereof. The two main issues involved being the patenting of life forms and the protection of plant varieties. The patenting of life forms is related to biopiracy, i.e., the theft of biological resources and traditional knowledge from developing countries. A U.S. patent on the use of turmeric for healing wounds is an example of biopiracy. The issue of IPR protection of the genetically engineered crops is also very important. The protection of plant varieties is important for commercial plant breeders. The International Union for Protection of New Varieties of Plants, UPOV, held its first convention in 1961 which promotes the protection of breeders' rights over the new plant varieties. The UPO Convention has been revised many times. Under 1991 revision, the breeders who register rights over varieties can claim full commercial control over the seed or propagating material of their protected varieties. Thus, the farmers can't sell the seeds from their harvest and they have to pay royalty even for the seeds that they save from their harvest for use in the next plantation. Recently, there was another development which could be used to exercise control and ownership over the biodiversity. With the help of new genetic engineering techniques, it is possible to create sterile plants with infertile seeds that can't be replanted. Thus, the seeds are killed after one generation. This technology is known as terminator technology. It forces the farmers to purchase seeds for every growing season. Hence, this technology offers an inbuilt protection without the needs of patents. The schedule for implementing TRIPS obligations for various categories of countries is as follows. Developed countries, developing countries, least developed countries, 1st January, 1996, 1st January, 2000, 1st January, 2006. The issue of patents and IPRs is a matter of concern for developing countries, as the private monopolization of life and of biological resources would adversely affect the development, food security, livelihood of farmers and the environment. Such patents are also being opposed by the people on ethical and moral grounds. A biosafety protocol has been signed by 65 countries on 25 May 2000 at the S meeting of COP to the Convention on Biological Diversity, CBD. It is the first internationally binding legal instrument, which regulated the handling, use and transboundary movement of GMOs. The details of the protocol are available at website http://www.biodive.org/do/publications/guide 3. ASP id equals action. EINT. The biodiversity in oceans is affected by dumping of toxic and hazardous wastes, oil pollution and thermal pollution. Toxic and hazardous wastes. including chemicals, can harm marine life. Oil pollution mainly results from the accidents between tankers and can kill many aquatic organisms. Thermal pollution results because oceans serve as sink for wastewater from industries and power stations. The hot water can raise the ocean temperature. Higher temperatures can cause enzymes and microbes to speed up and eventually can kill them. A change in temperature can also cause fish to migrate to different regions and can kill those species which cannot move away. Even a small change in temperature, L or 2 degrees Celsius, can have a considerable impact on marine life. 11.3 Global Issues. Global issues are so named because their impacts and damages affect not only the countries that cause the problems, but they go beyond their national boundaries and extend to the global scale. Also, the solutions to these issues require efforts at the international level. In this section, we would discuss some global issues such as ozone layer depletion, global warming and climate change, hazardous waste disposal and dumping, transgenics and weapons of mass destruction. 11.3.1 Ozone layer depletion. You know that our Earth is surrounded by an envelope of atmosphere that contains nitrogen, oxygen, carbon dioxide, ozone, water vapors, dust particles, and many other substances emitted as a result of a number of human activities. The atmosphere of the Earth can be divided into 3 zones, i.e., troposphere, stratosphere and mesosphere, as shown in figure 11.4. The stratosphere extends from 15 to 50 kilometers and the ozone layer is present in this region. Look at the screen. The air we breathe in contains oxygen, 0.2, in which 2 oxygen atoms are joined together, whereas in ozone, 0.3, 3 oxygen atoms are bonded together. The peak concentration of ozone is present in the stratosphere, being about 300 ppb, parts per billion, at about 25 kilometers near the equator and at about 15 kilometers in polar regions. This ozone layer of the stratosphere absorbs about 99% of the ultraviolet solar radiation. The ultraviolet radiation has wavelength between OLNM to 0.4 nanometers. It can be further subdivided into UVA, UVB and UV in the increasing order. Energy, see figure 11.5. The UVB and D are highly energetic and are dangerous to the life on Earth, whereas UVA is least energetic and is not dangerous. UVA is not absorbed by the ozone layer in the atmosphere, whereas most of UVB is absorbed and it's only 2% to 3% reaches the surface of the Earth. Thus, the ozone layer acts as a filter for UVB rays and protects us from the harmful effects of the UV radiation. UV is absorbed by oxygen and also by ozone in the upper atmosphere. The concentration of ozone is measured in Dobson unit, DU, where 1 Dobson unit is equivalent to 1 part per billion ozone. The measurements of ozone in the atmosphere began in 1957 by the British Antarctic Survey, which in 1985 pointed out significant ozone depletion over Antarctica during spring. The data indicated a decrease in the ozone concentration from about 300 Du in 1972, about 200 Du in 1984, which increased to around 250 Du in 1988 but dropped to approximately 88 Du in 1994. Thus, the general trend in ozone concentration showed a decrease since mid-1970s. This depletion of ozone or thinning of ozone layer is referred to as ozone hole. The depletion of ozone was also confirmed by the satellite observations. Studies also report depletion of ozone over the Arctic and the mid-latitude regions over areas of the United States and Europe. In 1974, Mario Molina and F. Sherwood Rowland suggested that chlorofluorocarbons, CFCs, are responsible for ozone depletion. The CFCs were used as propellants in spray cans used for packaging shaving creams, hair sprays, deodorants, paints, insecticides, etc. CFCs also find use in refrigeration air conditioning and blowing of foams, used in furniture, bedding, packaging, etc. The bromofluorocarbons, halons, are used as fire extinguishers, whereas other chlorine-containing compounds such as carbon tetrachloride, CCl4, and 1,1-I-trichloroethane, CHECB, are used as solvents and in dry cleaning. The CFCs are very stable unreactive compounds. They are present in the lower region of the atmosphere where they can stay unchanged even for about 100 years, as they have atmospheric lifetimes ranging from 75 to 140 years. When they reach the higher altitudes, they are broken by the UV radiation, and in this process the highly reactive chlorine atoms are released from them. These chlorine atoms then undergo a series of reactions and deplete the ozone layer. The decrease in the concentration of ozone allows more UVB radiation to reach the Earth, which has harmful effects on human health, animals, plants, microorganisms, materials, and air quality. Some of these are mentioned below. Effect on human and animal health. Exposure to UVB can cause cataract and skin cancer in humans. It also affects the immune system, thereby increasing the risk of infectious diseases. Light-skinned people can also develop non-melanoma skin cancer on exposure to UV radiation. Effect on terrestrial plants. The UVB radiation also affects the physiological and development processes in plants. The composition of the species can change, and hence the biodiversity would be affected. The changes in metabolism and plant form can also affect competitive balance, plant pathogens, and biogeochemical cycles. Effect on aquatic ecosystems, as the phytoplankton are the starting point in the food chain. Reduction in phytoplankton on exposure to UV radiation would affect the food chains. In addition, the UV radiation can also damage the early development stages of many aquatic animals. Effect on materials. UVB also increases the rate of degradation of polymers. Thus, the depletion of the ozone layer is a matter of concern worldwide. An international convention was held in Vienna on March 22, 1985, which led to an international agreement in 1987 known as Montreal Protocol on substances that deplete the ozone layer. A schedule was agreed to completely phase out the ozone-depleting substances, ADS, CFCs, halons, CHCH and CH. It was later found that the protocol measures were not adequate. Also, the developing countries needed both the technology and the financial assistance to switch over to non-ADS substances, as the depletion was much more than that predicted. In 1990, the second meeting of parties was held in London, where 54 parties and 42 non-party countries agreed that 5 CFCs and halons would be phased out by 2000. For developing countries with consumption of ODS less than 0.3 kilograms per capita, also called Article 5 countries, a grace period of 10 years was allowed. A multilateral fund was established with UNDP, UNEP, UNIDO and World Bank as the implementing agencies to provide financial and technical assistance to developing countries to enable them comply with control measures. During 1991 to 2000, over $813 million to more than 100 developing countries were disbursed under this fund. The Global Environment Facility, GEF, forges international cooperation and finances actions to address 6 critical threats to the global environment: biodiversity loss, climate change, degradation of antenna-al waters, ozone depletion, land degradation, and persistent organic pollutants, POPs. The GF has allocated $4 billion in grants and leveraged an additional $12 billion in new financing from other sources to support more than 1,000 projects in over 140 developing nations and countries with economies in transition. In August 2002, 32 donor nations pledged nearly $3 billion to fund the work of the GF for the next 4 years. GEF brings together 173 member governments, working in partnership with the private sector, NGOs, and international institutions to address complex environmental issues while supporting national sustainable development initiatives. India also belongs to the category of Article 5 countries. It acceded to the Montreal Protocol on 1 September 1992. 7 out of 20 substances controlled by the Montreal Protocol are produced and used in India. These are CFCLL, CFC12, CFCI13, Halo 1211, Halo 1301, carbon tetrachloride, and 1,1-L-trichloroethane. The Ministry of Environment and Forests, MOEF, coordinates all matters related to the Montreal Protocol. An ozone cell has been set up to support and help in the implementation of Montreal Protocol. Many projects are being funded by Multilateral Fund for Ozone Depleting Substances, ODS, phase-out and support activities. In addition, the National Ozone Unit, NOU, is entrusted with monitoring and implementation responsibility. Many fiscal measures including exemption from customs and excise duties and other benefits have been announced by the Government of India to those entrepreneurs who are shifting to non-ODS technology. The regulatory measures include ozone-depleting substances regulation rules, which have also been notified in the Gazette of India 1998 and cover several aspects of production, sale, consumption, export and import of ODS, etc. With the above initiatives and many other public awareness programs, India is trying to meet the following proposed phase-out dates for ozone-depleting substances. Manufacture of aerosol products 2003 excluding metered dose inhalers, MDI. Manufacture of foam products 2003 including domestic refrigerators. Manufacture of mobile air conditioners 2003. Manufacture of other refrigeration and 2003 air conditioning products 2003. Manufacture of products based on other ODS 2010. Manufacture of metered dose inhalers, MDI, 2010. Use of methyl bromide except quarantine and pre-shipment 2015. Manufacture of products based on HCFC 2040. More information can be obtained from the following. Director, Ozone, MOV, G01, India Habitat Center, Loti Road, New Delhi 1,10,003. Although the Montreal Protocol was signed in 1987 by 27 nations and it outlined a plan for the reduction of global emissions of CFCs to 50% of the emissions in 1986, but not all the chemicals which cause ozone depletion are covered by the protocol. Therefore, more UV radiation is expected to reach the Earth in next few decades by ozone depletion. The protocol called for elimination of production of CFCs by 1999, but as the depletion was occurring at a rate faster than rate predicted, hence the timetable for elimination of CFC production was shortened. Most industrialized countries stopped the production CFCs by the end of 1995, whereas the deadline for the developing countries is 2005. It is expected that if the Montreal Protocol and its amendments are fully complied, then in 2050 the concentration of CFCs would decrease to that in pre-1980. Even if the use of chemicals responsible for ozone depletion is stopped. Today the CFCs which are already present in the atmosphere would still persist for 200 more years. In addition, there are some more issues related to control the ozone depletion, which are as follows. The amendments to the protocol are yet to be ratified by many parties. Some countries whose economies are in transition are yet to implement near obligations. Illegal flow of CFCs to the industrialized countries. Some countries have begun phase out with a freeze only from 1st of July 1999. Global warming can increase ozone depletion. The interconnection between global warming and ozone depletion also needs to be studied. HFCs, which were used as substitutes for CFCs, can also cause global warming and are controlled by Kyoto Protocol. 11.3.2 Global warming and climate change. Climate refers to characteristic atmosphere conditions of a place over long periods of time. Climate can be classified according to latitude as tropical, subtropical, continental and Arctic. It is also referred to as Mediterranean, monsoon, desert type, etc. The temperature and precipitation are two important factors among others which influence the climate. Solar radiation warms the Earth's surface and the atmosphere. About 1/3 of the radiation is reflected back into space, about 20% is absorbed by the atmospheric gases, and the remaining amount reaches the Earth's surface and is absorbed by it. The energy so absorbed is remitted in the form of infrared radiation. The atmospheric gases absorb some of this radiation and hence do not allow all the emitted energy to escape into the space. Hence, some of the heat is trapped by these gases. Atmosphere becomes warmer. It is this phenomenon which raises the average temperature of Earth from -18 degrees Celsius to +15 degrees Celsius and is very vital for life on the Earth. The situation is analogous to a greenhouse which traps heat and its glass walls do not allow the heat to go out, thereby increasing the inside temperature. Hence, this effect is called greenhouse effect. Greenhouse gases such as carbon dioxide, methane, ozone, chlorofluorocarbons and water vapors are responsible for greenhouse effect. The contribution of water to greenhouse effect being about 2/3 and that of carbon dioxide being about 1/4. The other gases nitrogen, N2, oxygen, O2, argon, are present in the atmosphere are incapable of absorbing infrared radiation. The concentration of water vapors in the atmosphere has not changed significantly, but that of greenhouse gases has shown a marked increase since the Industrial Revolution. The anthropogenic, human, activities such as generation of energy from fossil fuels and deforestation have increased CO2 concentration. The increase in the concentration of CO2 and other greenhouse gases leads to an enhanced greenhouse effect. This causes an increase in the global temperature, which is known as global warming. Studies suggest that temperature is already increased by 0.3 degrees Celsius to 0.6 degrees Celsius since 1860, and the last 2 decades were of the 20th century warmest, particularly the year 1998. This global warming would change global climate patterns and would cause a rise in sea levels. It is estimated that the sea level may rise by 0.5 meter to about 1 meter by the end of this century. The rise in sea level is due to thermal expansion of water in oceans and melting of glaciers and polar ice sheets. This has serious implications for people living on coastal areas and islands. The other effects of global warming being a more vigorous hydrological cycle which may cause more severe floods, rainfall and droughts, and ecological changes affecting agricultural productivity and survival of forests. A warmer climate may also increase the infections or diseases such as malaria, dengue, yellow fever and viral encephalitis. The increasing concern about the climate change led the World Meteorological Organization, UNO, and United Nations Environment Programme, UNEP, to establish the Intergovernmental Panel on Climate Change, IPCC, in 1988. Its first assessment report was completed in 1990. The third assessment report includes results of research about changes in climate in last 5 years. It projects an increase in the surface temperature by 1.4 degrees Celsius, 58 degrees Celsius by the year 2100, which is higher than 1.0 degrees Celsius to 3.5 degrees Celsius as predicted in the second assessment report. Such a warming would be even greater than that which has occurred over last 10,000 years. If the rate of change's temperature is so fast, then the ecosystems would not be able to adapt to the change environment. The UN General Assembly decided to launch negotiations in December 1990, which started in February 1991. This led to the United Nations Framework Convention on Climate Change, UNFCCC, which was adopted in May 1992. It was ratified by 50 countries and came into force in March 1994. Today 186 countries are party to this convention. The convention aims to stabilize concentrations of greenhouse gases in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system within a time frame sufficient to allow ecosystems to adapt naturally to climate change, to ensure that food production is not threatened and to enable economic development to proceed in a sustainable manner. The parties to UNFCCC adopted the Kyoto Protocol in 1997, which requires the developed countries and economies in transition, Annex 1 countries, to reduce their overall emissions of greenhouse gases by 5.2% below the 1990 levels. In July 2001, Sixth Conference of Parties, 6 Colombian pesos, was held in Bonn, where a political agreement was held to help the countries to move towards the adoption of Kyoto Protocol. This agreement was formalized in October-November 2001 as Marrakesh Accords at the 7 Colombian pesos held at Marrakesh, Morocco. The United States unilaterally withdrew, but the compromises on key issues such as funding, technology transfer, adverse impacts of climate change and response measures, flexibility mechanisms, compliance etc. were arrived at. The 8th session of COP, 8 Colombian pesos, was held at New Delhi from 23 October, 1 November 2002. India is party to the UNFCCC. It signed the treaty on 10 June 1992 and ratified the same on 1 November 1993. As the greenhouse gas emissions by India are not very significant and in view of the low financial and technical capacities, India do not have binding greenhouse gases mitigation commitments. The Ministry of Environment and Forests is the nodal agency for climate change issues. India's contribution to greenhouse gas emissions. India-specific impacts of climate change-related efforts in India. Climate Change in Asia provides country-specific profile of 10 Asian countries with respect to status of climate change, key projects, regional status, publications etc. The climate change would affect pattern of rainfall and soil moisture. As the climatic factors related to agricultural productivity would change, there would be serious implications on food production. India is also highly vulnerable to climate change. Our economy depends upon climate-sensitive sectors such as agriculture and forestry. Also, our coastline is also densely populated and hence is under potential threat by rise in sea level. 11.3.3 Hazardous waste disposal and dumping. Waste material is the one which is unwanted and remains unused at the end of production process. A waste is said to be hazardous when it threatens human health and the environment when not properly managed. The hazardous waste is also sometimes called toxic waste, dangerous waste or special waste. It comprises chemicals, paints, heavy metals, acids and oils and is generated in various industries which manufacture many commodities aimed to give a comfortable modern living. A special category of hazardous waste is radioactive or nuclear waste, which is generated at various stages of a nuclear fuel cycle. A common problem with the hazardous and radioactive waste is the ambiguity and the inconsistency in their classification. There is no common international classification of radioactive waste. Different countries have their own classification depending upon the source, level of radioactivity etc. Hazardous waste can have harmful effects on the human health and the environment. The effect can be transmitted to atmosphere, water or directly by the dumping of solid waste on land or sea. The hazardous materials can get mixed with water and contaminate soil, rivers and oceans. They can also enter the food chains and pose threat to the resources and biodiversity. Some hazardous materials can cause headache, nausea, paralysis etc., while others have carcinogenic effects and can also cause genetic disorders. The famous incidents of Minamata Bay in Japan and Love Canal of the United States are the leading examples of the effects of hazardous chemicals on the human health and environment. In Minamata Bay, more than 100 people died, and a large number showed neurological disorders because of eating fish and shellfish which were contaminated with methylmercury discharged from a fertilizer plant. In 1930s, 21,000 tons of hazardous waste containing toxic chemicals such as benzene, chloroform, PCBs etc. were dumped at a site where the Love Canal was to be constructed by the Hooker Chemical Company. The she was covered for many years and was later sold to a school. Toxic chemicals seeped through the soil into the basement of the nearby homes, and people started having health problems. In India also, in the Bhopal gas tragedy in 1984, about 2,500 people died and thousands suffered from the long-term effects of exposure to the harmful methyl isocyanide (MIC) gas. During 1980s also, there were several incidents which drew international attention to the problem of transportation, management, disposal of hazardous and radioactive wastes. Some examples of such incidents are given below. In August 1986, 15,000 tons of municipal incinerator ash was loaded in a ship called Kensie in Philadelphia, which dumped 2,000 tons of the material on the shores in Haiti in January 1988. The rest of the waste was dumped probably in the ocean, because during its journey many countries refused its entry. The description of the cargo had also undergone changes, from general cargo to bulk construction material and lastly to topsoil ash fertilizer during the course of its journey. In 1987, 4,000 tons of chemical wastes were exported from Italy to Nigeria, on the persuasion of an Italian businessman who, in collusion with officials in Nigeria, managed the disposal of this waste at Cocoa in Nigeria. The leakage of chemicals resulted in harmful effects on the health of the people, and hence this illegal storage came into notice of the authorities. The impetus of the toxic waste were given death penalty and the cargo was transferred back to Italy. The wastes were ultimately incinerated in UK. The above incidents raise many issues related to the disposal and dumping of hazardous wastes. There may be false labeling, intentionally or unintentionally, regarding the nature of wastes. There is also a tendency of the advanced and developed industrial nations to dump their wastes in the developing countries by paying a very nominal price. The nuclear waste includes the waste generated at nuclear reactors, fuel processing plants, and the tailings from uranium mines. The tailings are the materials removed as a result of mining activity but are not processed and which remain at mining site. Nuclear waste also results from decommissioning of nuclear reactors. Research institutions and hospitals also contribute to this waste. The nuclear waste can be classified as low-level waste or high-level waste. The low-level waste contains low level of radiation and comprises residuals from chemical processing of uranium, contaminated equipment, tools, plastic, glass, clothing and other materials. If properly managed, low-level waste is not hazardous to the environment. High-level waste comprises spent fuel rods and other materials. It needs urgent disposal as it contains high amount of radioactivity and is extremely toxic. Geologic storage of such waste offers only a temporary solution. It also involves several issues which are as follows: selection of site and exploring it for geological stability, i.e., earthquakes, volcanic eruptions, groundwater movement, etc. Correct prediction of future changes of climate, erosion, earth movements, etc. at these sites with respect to time scale, as the waste would remain buried there for thousands of years. Opposition by people residing near these sites, NGOs, environmental activists in view of the risk and hazards associated with radioactive materials. Ocean dumping of low-level nuclear waste was followed by many countries, but due to the harmful effects of radioactive substances on sea life, some countries like US and Britain has stopped this practice. Basel Convention. The Basel Convention was originally designed to address the problem of uncontrolled movement and dumping of hazardous wastes, including the incidences of illegal dumping of hazardous waste by developed countries. The convention was adopted in 1989 at a conference held in Basel, Switzerland, and was ratified by 135 member countries and the European Union. April 2000. The convention came into force in 1992. The main aim was to minimize the generation of hazardous waste, the disposal of hazardous waste as close as possible to its source of generation, and to reduce its movement. Thus, under this convention, the movement of hazardous waste, or other wastes, can take place only with prior written notification by the state of export to the competent authorities of the states of import and transit. Each shipment of hazardous waste should be accompanied by a movement document from its starting point to the point of disposal. The shipments made without such document are illegal. Also, there is an outright ban on the export of hazardous waste to certain countries. The transboundary movement of hazardous waste can take place if the state of export does not have the capability of managing or disposing of the hazardous waste in an environmentally sound manner. Each member country which is a party to the convention has to submit information regarding the generation, export and import of hazardous waste. This information is compiled by the Secretariat and is presented in the annual report. These statistics are available at www.basel. The Basel Convention has regional centers for training and technological transfers in many countries including India. These centers help in the implementation of the Basel Convention. They also provide guidance on technical and technological issues. In addition, they encourage the use of cleaner production technologies and environmentally sound waste management practices. In 199:5 ban, amendment, the export of hazardous waste from countries listed in a proposed new annexure, member of EU, OECD, Liechtenstein, to all other parties to the convention is prohibited. In 1998, the Technical Working Group of the convention classified various specified wastes as hazardous or non-hazardous, while in 1999 the Ministerial Declaration set out the agenda for the next decade with emphasis on the minimization of hazardous waste. The 1999 Protocol on Liability and Compensation established rules on liability and compensation for damages caused by accidental spills of hazardous waste during export, import or disposal. 11.3.4 Issues in biotechnology. Biotechnology is the science of manipulating DNA. The use of transgenic technique, a sort of cut and paste technique, has made it possible to transfer genes from one species to another. Thus, by transferring a gene with desirable traits from one species to another, one can engineer plants as well as animals which have the desired characteristics. Such a tailor-made organism, plant or animal, is said to be genetically modified. For example, a genetically modified frost-free tomato has been produced by transferring a gene from fish living in cold water. Thus, desirable traits such as greater yield, drought tolerance, pathogen resistance, high nutritional content, herbicide tolerance etc. can be introduced into crops. Various crops such as corn, tomato, potato, soybean, cotton, melon, tobacco, sugar beet etc. are under field trials. Proponents of GM plants hope to feed the world's 3 billion malnourished poor by using this technology. It is also expected that with GM crops, our current over-reliance upon fertilizers, pesticides and herbicides would also reduce. The enhanced crop yield would also decrease the conversion of wild habitats into arable land. 82% of the world's GM crops are grown in US and Canada, whereas Argentina's share is 17%. Rest 1% GM crops are grown by 9 other countries. In India, the first transgenic crop, BT cotton, has been granted conditional approval by the Genetic Engineering Approval Committee, GEAC, for commercial cultivation. BT stands for Bacillus thuringiensis, a soil bacterium which synthesizes a crystal, protein. This protein breaks down to release a toxin in insect gut which kills the insect. The BT gene is inserted into cotton and the plant produces its own BT toxin. Such cotton plants are resistant to boll worm, which is a major cotton pest. In India, half of the pesticides used, i.e., 35,000 metric tons out of a total of 70,000 metric tons, are used to fight with the boll worm menace on cotton. The studies on BT cotton have shown an increase of 41 to 86% in yield and an increase of 17 to 77% in the number of bolls. The reduction in the sprays amounted to a saving of hours, 3,000 to 6,000 hectare. The transgenic crops such as BT cotton offer a route to increasing crop production with minimum use of chemical pesticides. The other crops such as mustard and chili are being tested by Pro Agro and Rallis India Limited, respectively. The three varieties of cotton, namely MH 162, Biotechnology MH 184, and Biotechnology MH 12, have been granted conditional approval. These varieties are suitable for central and southern cotton zones and northern zones of Punjab, Haryana and parts of Rajasthan. The approval has been granted to Maharashtra Hybrid Seed Company, Mohico, which has a tie-up with the multinational company Monsanto. The approval is for 3 years, i.e., from April 2000 to March 2005. Mohico is developing and testing Bt cotton since 1996. The two conditions for using Bt cotton are as follows. 1. Bt cotton may be sown on 80% of the field, while the remaining 20% area must be sown with non-transgenic cotton. The non-transgenic cotton should be sown on the peripheries of the field. 2. A minimum 5 rows of non-transgenic cotton should be grown on the peripheries. In spite of the great promises of GM technology, many countries have made it mandatory to label the GM foods and food products or have been banned them. This is because of growing concern on various aspects associated with this technology. The issues involved are the following. Safety of GM foods. Since new proteins are synthesized in GM plants, it is feared that these may cause a sharp increase in allergic reactions. Patenting of GM crops. In many developing countries, a common practice is to save seeds from the harvest and use them for planting next year. If the GM seeds are patented, then farmers would not have the right to save the seeds, and every time the seeds are to be purchased from the company who has patented it. Thus, some companies may monopolize the global farming economy. Creation of superweeds. About 70% of the GM crops are herbicide-resistant crops. It is feared that these would spontaneously breed in the wild with related plants to yield superweeds. In addition to being a threat to the ecosystems, these superweeds would require even more potent chemicals for their destruction. Threat to organic farming. The bacterium Bacillus thuringiensis, which was mentioned above in Bt cotton, is used by farmers in organic farming to control insect pests. They apply Bt only as per their needs. It is expected that if the insects are exposed to the Bt crops, they would develop immunity and hence the organic farming would be adversely affected. 11.3.5 Chemical, biological, and nuclear weapons. Nuclear, biological and chemical, NBC, or chemical, biological, radiological, or nuclear weapons, CBRN, are weapons of mass destruction. The most well-known incident of the use of chemical weapons, sarin nerve gas against the civilian target, was by AUM Shinrikyo, which was a Japanese cult group on the Tokyo subway system in March 1995. During Gulf War also, toxic gases were detected by Czech troops and about 4 lakh personnel were exposed to small quantities of nerve and mustard gases. Chemical weapons are the most common type of CBR warfare weapons. They amount to about 1/3 of the world's total arsenal. The weapons are classified by their effects, i.e., lethal, choking, hallucinogenic, etc. The first incidence of the use of chemical weapons was after end of World War I by the British against Kurds. The other chemical wars were between Egypt and Yemen in 1960s, Vietnam and Laos during 1970, Russia and Afghanistan in 1980, Iraq and USA in 1990. Chemical weapons can be classified into various types. Some categories of chemical agents, their examples and effects are as given below. 1. Choking agents, phosgene death from loss of oxygen. 2. Blister agents, mustard lewisite, large skin blisters, respiratory damage. 3. Blood agents, hydrogen cyanide, cyanogen chloride, interferes with body's oxygen supply and cause death. 4. Nerve agents, sarin taboon, soman loss of muscular control, respiratory failure and death. 5. Others, CNS, busy incapacitating agents. The biological weapons are infectious agents such as bacteria or virus which are used intentionally to harm others. They also include both living microorganisms, bacteria, protozoa, viruses and fungi, and toxins, chemicals, produced by the microorganisms. The oldest germs being anthrax, botulism and plague. The other examples of biological weapons include E. coli, dengue fever, typhus, mycotoxin, etc. Some of these are highly lethal while others can play a role in incapacitating. They can be immensely destructive because they multiply in right environment and can self-perpetuate. Since they can naturally mutate, the protective measures against them become ineffective. The botulism toxin is 3 million times more potent than the chemical nerve gas sarin. Anthrax, which was in news sometimes back in 2001 as it was suspected to be sent to people by postal mails in the United States, is a disease caused by the bacterium Bacillus anthracis. The production involves low cost and the methods are widely known as they do not require high technology. Anthrax is very toxic and can be stored as dry powder for very long periods of time. Viral agents infect the human body by multiplying, disrupting cellular activity and killing the target by passive convulsions or hemorrhaging. Viruses are also not affected by antibiotics. Biological warfare is very easy to start but very hard to stop. The biological weapons are invisible silent killers. They are matter of serious concern, as they know no boundaries. Similarly, nuclear weapons also pose a threat to the mankind as their number is increasing worldwide. The suspected total number of nuclear weapons in the world possessed by various countries is as follows: China 400, France 350, India 60, Israel 200, Pakistan 24 to 28, Russia -10,000. UK -185, USA I-0656. The two main types of nuclear weapons are fission and fusion types. The fission bombs were used on Japan in World War H. They involve uranium and plutonium as the fissionable materials. A 20% concentration of these material amounts the material to be classified as weapon grade. There are chances that plutonium can be smuggled from nuclear reactors and diverted for destructive activities. The nuclear weapons require regular maintenance which causes a heavy financial burden on economies. Thus, funds which are used for making these weapons in the name of defense and deterrence could be used for developmental activities and meeting the basic needs of the society. In view of the grave consequences of the use of chemical, biological and nuclear weapons, various initiatives to control their usage have been taken by agreeing international conventions and protocols. These are mentioned below. Protocol for the Prohibition of the Use in War of Asphyxiating, Poisons or Other Gases, and of Bacteriological Methods of Warfare, the Geneva Protocol, 1 IH June, 1925. The Chemical Weapon Convention, CWC. It prohibits the development, production, acquisition, stockpiling, retention, transfer and use of chemical weapons. It entered into force on 29 April, 1997. More than 170 countries have signed the CWC and 145 countries have ratified it. It stipulates that the stock of chemical weapons possessed by various countries would be destroyed in 10 years time frame. Full text of CWC. The Chemical Weapon Convention Handbook. Schedules of Chemicals. A list of signatories and ratifications. Convention on the Prohibition of Bacteriological, Biological and Toxin Weapons and of their destruction. The Biological Weapons Convention. It was signed on April 1972 at Geneva. Joint Declaration on the Complete Prohibition of Chemical and Biological Weapons, the Mendoza Accord. It was agreed on 5/1 September, 1991. 11. For activities. Browse various websites related to the issues mentioned in this unit. Make a list of useful websites other than those mentioned in the unit. Organize discussions, seminars, debates on these issues in your organization and compile people's opinion on these issues. Contact various NGOs and environmental associations active in your area and participate in their activities. Popularize, to the extent possible, these issues and concerns through schools/colleges/universities and by involving social workers to create public awareness. Display posters, banners, etc. related to these issues in your organization. Celebrate various occasions like the Environment Day, Ozone Day, etc. actively in your institution. 11.5 Summary. In this unit, we have tried to draw attention to various issues which are a matter of worldwide concern because of their harmful effects on human health and the environment. We have discussed transboundary issues such as nuclear accidents, with Chernobyl as the example. The direct as well as long-term effects of exposure to radiation resulting from such incidents were explained. Then the issue of threats to biodiversity was analyzed in the light of various factors such as desertification, IPRs and patents. Some global issues such as ozone layer depletion, global warming and climate change, which are debated at various levels, were addressed and their causes and effects were discussed. The problem of hazardous waste disposal and dumping, including the disposal of nuclear waste, was also undertaken. The recent researches in the area of biotechnology have resulted in controversies related to the use and safety of GMOs. Some such issues related to transgenics were also highlighted in this unit. The last section dealt with the chemical, biological and nuclear weapons. The discussion included examples, use and effects of these weapons. In all the sections, various agreements in the form of international conventions, treaties and protocols have been given to emphasize the measures taken to deal with these issues. Also, some useful websites have been mentioned at appropriate places so that more information can be obtained about various aspects of these issues. Thank you for listening. We will be back with next chapter.